Sustainability. That's one of those terms that we tend to hear, read, see quite a bit these days. But while we have an intuitive understanding, what does it actually mean? What does it imply? And why is digital sustainability gaining more and more traction among CEOs, CTOs, heads of something? And last but not least, but certainly dear to our hearts, what role can and does open source play there? Let's dive a little bit into the concepts and all those connections. Me, that's Gerald Pfeifer, CTO at SUSE.
And me, Martin Rohde, process engineer at SUSE. We've, thought about sustainability and how to tackle the topic from various kind of angles. But I thought the best way to approach this is perhaps to think about what others associate with the term first. And when hearing the term sustainability, a lot of people, they may associate, things like ecosystem protection, renewable resources, and, just generally environmentally conscious topics. And we thought that this is a good way to essentially approach the topic. Like, one way on a conceptual level to talk about environmental sustainability would be to think about what options there are to reduce electronic waste, to extend, hardware and software life cycles, or to think about, what kind of potential is there to save resources through energy-aware practices. Now, with that, we mean engineering and energy-aware operations. This could be done through, certain clean code practices, or just generally, reducing unnecessary software packages, which are, increasing the footprint. We have various options there on an engineering level. Also in the educational sector, and as we shall see later on, open source desktop usage in schools, for example, is also playing a significant role in extending hardware life cycles. But the last point we'd like to mention is that there are also new ways and tools to collaborate. Obviously, not only since the pandemic, but long before, open source developers and engineers, they were used to working remotely and often actually without physically meeting one another. And that's actually also quite a resource efficient way of doing so. And they went through different iterations of their tools. So in the early times, perhaps collaboration features, were mainly restricted to mailing lists. After that, with the invention of Git, different kind of tools and software repositories came up, such as GitLab or Bugzilla or GitHub, SourceHut, and so on. So there are various changes along the way, and also surprisingly, ways which have been already resource efficient, from the early times. On a more practical level, we could think of the Cardano Group. That's a risk and investment specialist, and as part of their container strategy and ultimately the switch to SUSE Rancher, they also evaluated their energy footprint. And now what they were capable of doing is that they reduced their entire energy costs by roughly 75% by essentially powering down non-production services overnight.
Ecological sustainability is one aspect. Another key one is economic sustainability. And what comes into play here is what we call the power of many and the economies of scale that creates, and that in particular open source helps create and nurture. Think about this. The majority of developers of our products on the SUSE side, but equally most open source vendors, doesn't actually work for us, aren't SUSE employees. Because we work in communities. We work in communities together with volunteers, with partners, with customers, with competitors, universities and others. And an approach that I've seen again and again as a very successful model is to jointly work in that common ecosystem or those common ecosystems, build common bases, build foundations, platforms like the Linux kernel or Kubernetes, and then differentiate on top. So consume, provide, share, build on top, and maybe repeat that at that level and at another level. And in general, what we have seen over the 2+ decades of open source is openness, collaboration really begets innovation. One of my favorite examples is something that Knorr-Bremse did. Knorr-Bremse is an established company. They have sizable production floors with like really heavy duty equipment. And as you can imagine, the life cycles of those equipment runs into 10 years, 15 years. And so some of those or most of those actually don't have internet connectivity, have lots of sensors that you can probe and then take action. And so what they did is they took Raspberry Pis, so really cheap pieces of hardware. They took SUSE Linux Enterprise, equipped that with sensors, networked them, and used them to measure and probe different aspects of that equipment. And what they accomplished there is increasing the life cycle of that hardware, but also improving the efficiency, improving maintenance, and other practical aspects, which definitely has an impact economically, but also ecologically.
Now, when we think about open source, there's another layer that comes into play here, and that's sort of the third pillar we'd like to introduce today. And open source can be, conceived as an assemblage of technologies, people, and their practices, and especially the practices arising from the interaction of people with the technology that they produce. Now, open source is not just about access to the source code, even though that is one of its central and defining characteristics. So in that sense, open source is very much accessible. So anyone with access to a computer and a software hosting solution like, let's say, GitHub or GitLab can actually contribute. But more than that, open source is, by its nature of its licenses, about redistribution. It is about sharing. And at the heart of all of this is fundamentally collaboration. People get together, they work together, they may review code. Some may do so in an entirely non-technical manner. For example, this could be, not through coding, but in some other form, through writing, maybe technical writing, maybe design, even though that's in itself also a technical arena of its own. And some others may contribute through translation. So it's a wide mix of contributors that are coming together to collaborate and work on an open source project. And lastly, open source is also a social movement. Now, this may be nothing new to some of you, but it may come as a surprise to others. And interestingly, the Encyclopedia Britannica, they actually picked up on this notion of social movement and defined it essentially as creative work in favor of decentralization, in favor of transparency, and the open sharing of information. Now, on a more practical level, we can think of the Westcliff High School for Girls, for example. They support a wide variety of free and open source software, among which open source plays a wide role, obviously, and also OpenSUSE plays a wide role, in that it powers actual student desktop computers. They've chosen OpenSUSE simply because also of the wide repositories that are available and the ease of use on the desktop system, and that makes it easy for students to work with. And now also, if you look at this in a more broader sense, there are various educational responses, especially during the pandemic, the COVID-19 times, with different kind of open source solutions. So, for example, in Macedonia, some schools, they were essentially setting up open source LMS systems or learning management systems such as Moodle to cope with the challenges of remote education.
To put things together, we've seen there is ecological sustainability, there is economic sustainability, and there's social sustainability. And those overlap, as we have seen in the previous examples, Cardano obviously saving power is an ecological improvement, but also shows on the bottom line. The examples Martin showed definitely have social aspects, but also economic aspects. And if you increase life cycles or allow and support remote collaboration, that has an ecological footprint. Now, in all fairness, when I engage with customers or partners, those do not tend to be the words that primarily come up. Rather, it's words like resilience, requirements, desires to be resilient. It's about innovation, and it's about freedom of choice that come up. And it's not a coincidence how we have depicted this here on the slides. Those concepts between sustainability and what we label digital sustainability here, namely resilience, innovation, and freedom, actually map rather well and play together.
Let's take resilience, one of the key terms that frequently came up in those conversations. And let's take a short thought experiment. Imagine you're a Chinese cell phone manufacturer and you suddenly don't have access to, let's say, redistributive rights of the software platform that you'd like to use. Now, how do you react? What are your options? What are your available options to react to that kind of geostrategic situation that you find yourself in? So in general, political or business decisions may actually undermine your foundation. And the ability to react to that can be pretty much summarized, with the term resilience. Now, the key question here that we've asked ourselves is now, why does open source strengthen resilience? Now, one way it does so is because with open source, you can maintain a range of motion or a range of freedom despite unfavorable, let's say, market conditions or governmental restrictions, maybe even export restrictions that you may be faced with. Now, open source provides a much more robust foundation in case, let's say, a company discontinues a product, or in case geopolitical considerations they might affect, the continued use of a product, maybe due to export restrictions. Now, if it is open source and the code is, openly accessible, you are, as by nature of or definition of its licenses, you're free to fork the project and continue with it with a range of developers of your own. But also in the open source world, and that's maybe important to mention as well, repositories are also at risk, sometimes because of the vulnerability of the organizational structure that actually supports it. So in order to achieve sustainability in that sense, it is important to have, as an organization or as individuals, the ability to seamlessly migrate to alternative repositories if that, in case that becomes necessary. And on another level, we can think of, the interplay between resilience and open source as the ability to adapt. It essentially goes beyond the mere fact that you may have resources, financial or otherwise, to be able to react quickly. But in order to be truly resilient, the root, so to speak, must have been planted in the past. And this is where open source plays an essential role. And at some point in time, a company may have decided to build their products on an open source foundation, as we have seen in the economic pillar, and be able to develop in a much more robust fashion. A last point we'd like to mention is the term digital sovereignty that frequently comes up, especially in the European sphere, in the European Union. And interestingly, the Competence Center for Public IT in Germany has defined this somewhat along the lines of the ability and opportunity of individuals and institutions to essentially execute their role in the digital world independently, intentionally, and safely. And we believe that is clearly connected with the ability to be resilient.
Martin mentioned companies basing products on open source, and that's what we at SUSE do. In fact, that's what we do across the portfolio. And one way to go about that is actually nurturing innovation at the base level in the context of open source projects, creating open source projects, creating new aspects of open source projects, or maybe creating something inside an existing project. OpenSUSE MicroOS is such an example where looking at the need to have a solid base for container environments, but also looking where IT and OT move more and more towards the edge. And there's quite some resilience necessary. You don't have specialized staff, but you do have very often huge numbers of devices. And so some of the requirements that were put on the table are around predictability, reliability, but also immutability of those platforms. And hand in hand, having atomic updates, which means when you update a device in the field, when you update one of your container hosts, either the update goes through completely or it doesn't. And if it doesn't, it reverts to the previous states. And pretty obvious, everything needs to be secure. So what Richard Brown, a colleague of ours, and some others actually did is they looked into the open source toolbox. They looked into what we had in terms of operating system, what we had in terms of Linux kernel, how they could create a smaller version of an operating system. They leveraged aspects like snapshotting, restoring of systems, of file systems, etc. And then they added very specific pieces for that use case. And that's one of those success models around open source, looking what's out there, taking, adapting, combining freely, and then sharing on. And what those concepts also allow for is actually surprising direction, surprising innovation, because based on MicroOS and realizing those requirements actually could be useful for desktop environments too, there's some volunteers, and Richard supported them, who said, let's create OpenSUSE MicroOS desktop. Use the same base technologies, see how we can add desktop functionally on top of that, and then release it, see whether there's volunteers who are interested to contribute, whether it's users, what their feedback is. And this working together, this coming together of bright minds, of minds from different backgrounds, engineers, users, very technical people with a design background, etc. That really is a unique aspect of open source. And if you combine that with the sharing of ideas, but also the sharing of code, the sharing of experiences, that's a huge innovation machine. And based on that, there is ecosystems forming. Some of them are formal, some of them are just informal, like people getting together on mailing lists, people getting together on some of the tools Martin mentioned, and create foundations. And foundations sometimes in the sense of a Linux foundation, but also foundations just as in building blocks for more innovation on top and on top. And everything Martin and me are covering today is, of course, applicable to software, hence the term open source, but it's equally applicable to processes, to services, and goods in general.
Now, if we look at the third key term that frequently came up, freedom, how does that interface, how does that interplay with open source? Now, if we look at this on a more practical kind of best practices level, we can think of the life insurance company WWK. Now, they significantly increased the freedom and flexibility beyond a single vendor ecosystem. So they've avoided vendor lock-in, and they've enhanced the flexibility with open source solutions. Now what they've did is they essentially in their container strategy ultimately opted for SUSE Rancher, and with this they had the ability to work with any third-party solutions through integration via its Helm chart catalog. Now on a more conceptual level, now how are freedom and open source connected? Now, in one sense, freedom reflects the possibility, to choose among a range of options. Freedom can appear on different levels. It can appear on a hardware level, maybe through the ability to migrate applications from one platform to another. It can be that particular software is developed for a different platform, for different hardware platforms. It can be on a software level in a sense that you're able to integrate different third-party solutions into your existing stack, so you don't have to, buy one stack from one company, but you can essentially, mix that with the solutions you already have in place in-house. Maybe you're developing some solutions in-house, and you're able to, interoperable, have better interoperability among them. But in open source projects, there may also be different engineering practices, that we can look at. And two questions that came up here is like, how is open source developed, and why is it developed? And we can look at this at these two conceptual levels. Like on the how level, you can think of the means of how technology is engineered. It's essentially engineered in a collaborative and transparent fashion. And on the why level, so to speak, this could refer to the ends towards which technology is engineered, and we can think of the obvious goals behind that is to increase flexibility and interoperability for those that are actually using or implementing the solutions. And both, in that sense, increase the range of motion, increase the range of freedom that is available. And lastly, maybe one final look at it. Freedom can be defined as more as a negative kind of freedom or as a positive kind of freedom. A freedom in a negative sense would be freedom from vendor lock-in. So essentially, that would mean without interference from others. And on a more positive level, you can say the positive freedom would kind of refer to your freedom to choose. So essentially, you are the source of control to decide, to choose for a particular solution or a particular element in a software stack. So this is sort of the roundup of negative and positive freedom in that context. And we'd like to conclude maybe the final words to Gerald.
Yeah, so be it classic or general sustainability, where ecology, economy, and social play together, or digital sustainability, where we looked into terms like resilience, innovation, and the various freedoms, you can make a difference. We can make a difference. And open source definitely does make a difference. Thank you.